We're being asked to state the domain of a function, which the first time you're looking at this is always a little bit confusing. So what you really need to keep in mind to make this as obvious as I'd like it to be for you is that the domain represents the x values that we're allowed to use. And the reason why this might seem like such a weird question is because you've always just been told which x to use, but now we need to say of all the x's that could work, which ones are we actually allowed to plug into the function. And at this point in your math career, what you should understand is that we can pretty much use any x we want. You can plug anything into a function that you want to, as long as it doesn't make you divide by 0, and as long as it doesn't make you take the even root of a negative number. So as you look at these equations that you're trying to find the domain of, you are going to be looking for places where you might have divided, like in this function where we have a division going on, or things that are underneath an even root. And we want to guarantee that we don't plug in an x that makes this 0. We want to guarantee that we don't plug in an x that makes this negative. But if these two types of things are not happening, then your domain is going to be it will be all real numbers. So for this very first example, what's the domain of 2x plus 8? Which x's can I plug in? Well, there's no chance I'll divide by 0, and there's no chance x will make me square root of negative, so it's going to be all real numbers. For the second example, number 2 here, I want to make sure that I never ever divide by 0. So if I can figure out whatever x's make this division part 0, I need to exclude that from my domain or not have it in my domain. So we're going to rely on some unit 2 skills here. We're going to take this x squared plus 5x plus 4. We're going to figure out what makes that equal 0. And then we're going to say x can be everything except for those things. To solve this, I would first try factoring. And I can factor this in this way. I will then, of course, find the zeros of these factors because we are trying to solve this for 0. As I solve these equations separately, I see that if x equals -1, this expression equals 0. If x equals -4, this expression equals 0. So basically, my domain is going to be all reals except -1 and -4, which you could also just write as x cannot equal -1 or -4, and people will know what you mean by that. If you don't believe that this is a problem, take this -1, plug it into this function, and see what happens. Your calculator should give you an error because you'll be dividing by 0. For the third example, I have an even root, and I have the even root of the expression 4x minus 8. So I want to guarantee that whatever x I put into this expression, it doesn't make a negative number come out. Like for example, I wouldn't want to let x equal 0. Because if x were to equal 0 and I were to plug 0 in for x, I would get the square root of -8. That's not going to be a good thing. If I were to let x equal 1, that'd be bad. If I plug 1 into this expression, I get the square root of -4. You can't do that. But I don't want to sit here guessing and checking like a chowderhead. That's not a good way to go about it. That's not math. So we just want to guarantee that this is not negative. For this to not be negative, it needs to be bigger than or equal to 0. So I'm going to take the expression under the even root. I'm going to say it must be bigger than or equal to 0, and I'm going to solve this thing for x by adding 8 to both sides, dividing both sides by 4, and getting the expression x has to be bigger than or equal to 2. So what this is telling me is that as long as x is bigger than or equal to 2, 4x minus 8 is not negative. This would be my domain for this function. Good luck with this.